Hello all. In this session, we discuss about the measurement of a pH by using an ion selective electrode. An ion selective electrode, we call it as a glass electrode. It has an ability to respond to only a particular ions. It can ignore all the other ions, but it can respond to a particular ion and it develops a potential. The potential developed by this ion selective electrode depends on the concentration of the particular ion. Here, the glass electrode, in which it contains a glass membrane at the bottom, has an ability to select only the H plus ion in the mixture of the substance. This is the diagram of the glass electrode. We call it as internal reference electrode. It contains a glass bulb at the bottom. The glass bulb is made up of a membrane, a special membrane, which is an ion selective membrane. And inside the glass bulb, we have a 0.1 molality hydrochloric acid and a platinum wire is being merged in it. So it is a thin wall bulb and there is a platinum wire and 0.1 m hydrochloric acid. HCl in the bulb furnishes a constant H plus ion concentration. It is an internal reference electrode. The equation Eg equal to E naught G. E is the EMF, or we call it as electrode potential. This electrode potential of a gas electrode equal to standard electrode potential of the gas electrode E plus 0.0592 P. 0.0592. This has been derived from this Nernst equation. This thin wall gas bulb contains a glass membrane and it is like an ion exchange resin. It maintains an equilibrium between the sodium ion and the H plus ion in the solution and the glass. The potential difference varies with the percent of the concentration of H plus ion, which will be given as an expression of EMF. So this is an experimental setup to measure this voltage. One end, we have connected a calomel electrode, which is connected to a potentiometer. And other end, the glass electrode, which has been connected to the potentiometer as a negative end. So now what happens? Depending upon the pH of the solution where the glass electrode is being immersed, the potential difference is being measured by the potentiometer in volt. And calomel electrode, it indicates we use a saturated calomel electrode. The saturated calomel electrode has a standardized electrode potential value, and based on this, we can calculate. So E cell equal to E right minus E left. The right hand side, it is a calomel electrode, and the left hand side, it is a glass electrode. As I said you, the calomel electrode has a constant value when you use a saturated one. So the final equation arrives like this: pH equal to E calomel minus E naught glass minus E cell by the value obtained from Nernst equation 0.059. So E calomel has a standard value that is 0.2422 and E naught G minus E cell is observed from the experiment. Based on these values, we can calculate the pH. So the glass electrode is highly useful to understand or to maintain the pH. Not maintaining, it is measuring the pH of a solution. So advantages of this glass electrodes are: it is easy to concept, it is already available, just dip it and connect to the potentiometer. And the results are highly accurate and it is not poison. That means the platinum is outside. There will be a platinum poisoning by the other materials, but it is safely present inside the hydrochloric acid. So no poisoning has been obtained to the platinum. And equilibrium is immediately and rapidly achieved. So there is a quick measurement of pH by using this electrode. Disadvantages is, since the resistance is quite high, So the special electronic potentiometer should be used. And this gas electrode can measure only the pH up to 0 to 14, but pH scale is up to 14. So above 10 up to 14, it cannot be used to measure it. The pH nearly or above 12 is highly alkaline one. So cations of this solution, particularly the glass, get affected by this alkaline solution. And generally it is above 10, it is a useless one. So between 0 to 10, it can be used to measure. So application is, it has enormous application. It is used to understand the concentration of the cations like H plus, Na plus, potassium, etc. Even anions can be also measured like MO3 minus, Cn minus, etc. And this electrode is used in determination of concentration of even the gas. That means this particular electrode is a gas sensitive electrode. So it's a gas sensitive. So it can be used in gas sensor devices. Electrochemical series, other one, to understand the arrangements of metals in a particular order, so that which can be used to construct several cells. So electrochemical series or EMF series is nothing but an arrangement of the metals or the elements in the increasing value of standard electrode potential on hydrogen scale. See, the hydrogen scale is 0, and above it has a negative electrode potential. Below it has a positive electrode potential. So the things which have a positive electrode potential can be used as a cathode, and which has a negative electrode potential can be used as an anode. By using this anode and cathode, we can construct a cell. So the main advantage of this electrochemical cell is it can be used to understand how a metal acts. It acts as an anode or a cathode. Thank you.